whenever we solve linear systems algebraically. So there are two different ways to do it algebraically. We talked about graphing yesterday. Algebraically is you're going to solve it for a particular variable. Okay? In certain cases, there are certain ways that will be better than others. First one is going to be whenever you use substitution. A couple steps. Solve one of the equations for one of its variables. Pick the equation that's easiest to solve. Okay? If you have a variable that is a lone variable and it does not have a coefficient, that is the one you want to solve for. Okay? So if you have everything like that has a coefficient in front of it that is not a 1, then I would suggest using something other than substitution. Okay? If you have a variable that does not have a coefficient in front of it, substitution is just fine. Okay? But it's not one of those, there's really never a method that's better than the others. Okay? It just depends on from problem to problem. I would not get into the habit of saying, I'm going to do every problem this way, and I'll explain, you'll figure that out on Thursday as far as why. So once you pick an equation and solve a variable for the easiest one, substitution, so substitute the expression into the other equation and solve. Once you get either your x or your y value or your a or your b, whatever letter you have, then plug it back into the original one that you manipulated. Okay? And then that'll give you your answer as terms of a coordinate. So if I have 3x plus 4y equal to negative 4, and x plus 2y is equal to 2. So the first thing that I want to do, which one is going to be the smarter one to manipulate? The first one or the second one? Which one has a variable that has a coefficient of 1 or does not have a number in front of it? The second one, right? Okay. So I want to manipulate it to where I solve it for x. So I'm going to subtract 2y from both sides, and this is just going to turn into, I'm just going to rewrite it right above it and have x is equal to negative 2y plus 2. Now, whichever one I manipulate, okay, and whenever I say manipulate, whichever one I change, if I have to, then this part right here is going to get substituted into the other equation. Okay? So whichever one has x equals, or y equals, or a equals, or c equals, whatever letters or variables we're using, I'm going to take everything else that's on the other side of the equation once I get that variable by itself, and I'm going to plug it in for that variable. So the negative 2y plus 2 is going to get plugged in right here. So instead of x, I'm going to have 3 times negative 2y plus 2 plus 4y equals negative 4. All I did was change the x to what is in this box over here. It's the same equation, it just substituted what I had. Now it just becomes solving for a variable. I'm going to solve everything for y. So I need to distribute the 3. So I'm going to have negative 6y plus 6 plus 4y equals negative 4. Combine like terms. I'm going to kind of do two things at once. I'm going to combine like terms, and I'm going to send the 6 over to the other side. So whenever I do that, I'm going to have negative 2y equals negative 10. and then I'm going to divide by negative 2. So my y value is a positive 5. Now, I am not finished. I only have one variable. I have to solve for x and y. What would be the smartest place to plug y equal to 5 in? The what? Second equation. Where at in the second equation? Yeah, the place, I'm just going to take it to the one that I manipulated, and I'm going to plug it in right there. So I'm going to get x equals negative 2 times 2. Oh, negative 2 times 5, my fault. Negative 2 times 5 plus 2. So, negative 10 plus 2. X is equal to negative 8. So, write it as a coordinate. So, negative 8, 5. Now, what should we probably do? Just like whenever we graph, what should we probably do? Are we just going to say, yep, it's right, that's what we're going with? Probably check it. Now, whenever you check it, I would not check it with the one that you manipulated. Okay, because you already plugged the 5 into the negative 2y plus 2. So I would plug it back into one of the originals, mainly the one that I didn't use. 3 times negative 8 is negative 24. 4 times 5 is 20. Negative 24 plus 20 is negative 4. Everything checks out. Okay? So it's good. Oop. So substitution is not bad. Is a bad thing as far as, you know, I've had people ask, you know, where can once I get the 4, x equal to 4, where can I plug it in? Just plug it into the one that you have as y equals, because if that's the one you made y equals, okay. Now here's one question I do have: how many of you moved the 2x over to the right side and then divided everything by a negative 1? Okay, that's fine. You made yourself. It made it a little tougher on yourself. Okay, if you have anything that's negative or a subtraction and it's by itself still, just move it to the other side and you can make it positive really simple. Okay, 2x minus 9 equal to y is the same thing as y equal to 2x minus 9. Okay, so wherever you have if it's a negative, then I would just move it to the other side. It's going to make it a lot easier. Okay, flip over to the back side. Then when we use elimination, to be perfectly honest with you, is probably going to be the one that's going to get used more than any. Because you're eliminating, it's probably been called like linear combination or something like that. It's just elimination. You're eliminating one of the variables. Okay? You're going to eliminate it, and then you're going to come back and figure out what it is later. So in some cases, there may be some that are easier to eliminate than others. In some cases, you may only have to multiply one equation by a value. In some cases, you may have to multiply 2. In some cases, you may have 2 numbers that match and go from there. So I want to get 2 variables to where they have the same coefficient. Okay? I'm not so much worried about the sign right now, okay, as I am just getting 2 values to match. So on example 1, you have 7x minus 4y equal to negative 3 and 2x plus 5y equal to negative 7. Which one do you want to get rid of? Which one do you want to match, the x or the y? It doesn't matter to me, and there's not a wrong answer. Which one do you want to eliminate? You want to eliminate the x, okay? So if I want to eliminate the x, I need to get the x's to be the same value. So what do I need to multiply the top by, and what do I need to multiply the bottom by to where they have the same number. 7 and 2, or 2 and 7, I guess, rather, is a better way of saying that. So if I multiply the top side, everything by 2, and I multiply the bottom side, everything by 7. Now, it's not always going to be the case where it's just the opposite number. Okay? And I wouldn't get into the habit, like if you look at number 2, I wouldn't get in the habit of saying, yeah, I want to multiply the top one by 12 and the bottom one by 9. Okay? Those are going to be really big numbers. Okay? Try to get your numbers to be as small as possible. Okay? In some cases, you have no choice but to multiply by the opposite coefficient. So what I'm going to do, and I'm just going to take it out to the left, I'm going to leave everything stacked, and I'm just going to distribute that 2 to everything inside. So I'm going to distribute that 2 to everything in here, and I'm going to have 14x minus 8y equals negative 6. On the bottom side, I'm going to multiply everything by 7. So I'm going to have 14x plus 35y equals negative 49. Now, I usually just draw a line underneath it because I'm just going to do just simple adding and subtracting. Now, I have a 14x and a 14x. So I either need to eliminate by addition or subtraction. How am I going to get the x's to eliminate or go away? Do I need to add them or do I need to subtract them? Subtract them, okay? So if I subtract, that means I have to change every single sign on the bottom. So what that means is, all I'm going to do, and here's how I like to do it, just so I don't get confused. I don't like just drawing a line through a minus. What I do is I just change my sign and I will circle it. Even if it's a plus, I will circle above it so then I know that's what my new sign is. So 14 minus 14, they go away. Negative 8 minus 35. Negative 43y. Negative 6 plus 49. I forget about that negative that I had there because I changed the sign. So what's negative 6 plus 49? 43. So I have 43. Now just solve for y. Divide by a negative 43. Y is equal to negative 1. So there's one piece of the puzzle. I need to take that negative 1 and plug it back in for y into one of my two original equations. It does not matter to me which one you plug it into. I don't care if you plug it in the top one. I don't care if you plug it into the bottom one. Which one do you choose? Top? Okay, I heard top first. So I'm going to go 7x minus 4 times negative 1 equals negative 3. So I have 7x plus 4 equals negative 3. I'm going to subtract 4. 7x equals negative 7. And x is equal to negative 1. So, write it as a coordinate. So, negative 1, negative 1. Make sure you put those in the right order. Yes? Or, which one do you want to match? The x or the y? The y? Okay? If the signs are different, that's okay. Okay? They don't have to match. You just want to make sure that the coefficients are the same. I'm not really worried about the sign until that's just going to tell me if I'm going to add or subtract. So do I need to multiply both of them or just one of them? Just one. Which one? the top one. So all I'm going to do is I'm going to multiply the top one by 2. And whenever I do, I'm going to end up getting 14x plus 4y equal to negative 6. I'm just going to rewrite my bottom one. So negative 14x minus 4y equals 6. What's going to happen? Now, signs are different, so I don't have to worry about anything. What's going to happen? Everything goes away, right? Those go away, those go away, those go away. So I have 0 equal to 0. Is that true? All real numbers. Now, I will tell you, if you have one that you have like 6 equals 0, like say all the variables cancel, but yet you still have a number over on the other side with your constant. What do you think? Like if it would have ended as 0 equals 2, what do you think your answer would have been? No solution. Okay? If it ends up being 0 equal to 0, it's all real numbers. It's every value that you can think of for x, because it's two lines that are on top of each other. Whereas if it ends up being like your x's and your y's cancel, but you're still left with a constant number on the other side of the equal sign, then it's going to be no solution. Okay? I'll post